In this lesson, we're going to focus on using some relationship, either a word relation or a calculation, to come up with a table of values and then to graph these and find the pattern on the graph. So we're going to be doing we're going to use a relationship expressed in an equation and come up with a table, which then gives us the geometric or graphical interpretation of this relationship. So here's our relationship. This person is getting paid $7 an hour, so we multiply that by the number of hours worked, which gives us the total pay. So relationship is the hours worked and the total pay. So let's establish what our dependent and independent variables are. Our hours worked should be our independent variable. Okay, that's our input. And then our output is going to be the total pay. So that's our dependent variable. Okay, our total pay ends up in a dependent variable. That means our total pay should end up along being graphed vertically, and the hours worked should be graphed horizontally. Okay, so let's use our relationship here to calculate the total pay to get connect our domain with our range, or our input with our output. So 4 hours times $7 an hour gives us a total pay of $28. So when I graph that, it's going to be 4 and 28, maybe somewhere about there. 12 hours times $7 an hour, that's going to give us $84 of total pay. So $12 we're going to get about up here for our total pay. 18 hours times $7 an hour, well, 10 times 7 is 70, 8 times 7 is 56, so adding those together I get $126 of total pay. So at 18 hours, okay, 125, it looks like it's going to be 150 is about here, so 125 is right about there. Okay. And at this point I can kind of see that these dots seem to be lining up, so it looks like there's a straight line pattern here. And one thing that does characterize these straight line patterns is this constant multiplier or constant rate often implies a linear relationship. So continuing on here, 25 hours times $7 an hour. Okay, it looks like that's going to be $175. Okay, so at 25 hours, I'm going to go all the way up to $175. Again, it seems to fit our pattern. 30 hours worked, we're going to end up with $210. Okay, so 210 is maybe right about there. And again, it looks like our pattern looks like it's about right. It's a straight line. And I would assume maybe that if I don't work any hours, I get zero pay. So it looks like it's probably going to go through zero. So there's my pattern. That's what I'm looking for. I'm not looking for the dots. I'm using the coordinates of our input and output to establish the relationship, which is a line. Okay? So that looks about right. And again, I think I mentioned in another video that these straight lines seem to kind of go up in steps. Okay? And these steps seem to have kind of a ratio. So here I gained 6 hours. I gained $42. Okay, 6 hours, another $42 or so. Okay, so it looks like we have this constant or ratio of change, okay, which is shown in these steps. And if these steps are the same for along that line, we know that that line goes up in a straight line or a constant slope. And this rate of change, $42 for every 6 hours, seems to have something to do with that $7 an hour. In fact, looks like that's my unit rate for the change that I see on the table. Okay, the ratios can be simplified into unit rates, and that seems to be the unit rate there. So let's put this into function notation. Our input independent variable is our hours worked, and the output is our dependent variable. So in function notation, my output should be my total pay. My input is x, so I'm going to write it as f of x, and it's going to be 7 times the number of hours worked gives us our output. So that looks like that is going to be our equation. In fact, we can kind of see that if we just switch this with y and x, yeah, that's y equals 7 times x. Okay, and again, I'm just going to highlight here. That's our output. F of x is our output. Okay, x is our input.